All right, so as promised, let's do a little bit of a review on logarithms. Logarithms are the inverse function of exponential functions. So if I have, of course, let's say I have some base 10, b is my base number, and let's just say my exponent n is equal to 2. I can take b to the power n, which is 10 to the power 2, and I get 100, right? And so in the case of this function here, this this formula here, x would be 100. It's probably pretty ugly. And so what is a logarithm? Well, a logarithm is saying, let's say I have some base 10, log base 10, and I want to know what exponent do I need to put this number to get a value of 100, right? So I am saying that my base number is 10, and I want to put 10 to some number to give me 100. What is that number? That's what a logarithm does. Okay, so in the case of log base 10 of 100, I guess I should probably leave this here. Let me just move this over here so that we know that this is basically what our log is telling us. So the value n that goes here, right, that's what we find. So log base 10 of 100, what number do I need to take 10 to the power of in order to get 100? Well, we know that that would be 2. So log base 10 of 100 is 2. Log base 10 of 1,000 is 3, right? And log base 10 of 1, or log base anything of 1, is equal to 0, right? Because anything to the power of 0 is 1. Okay, so that's just a brief review on what logarithms are, what they actually do. And when I say they're the inverse of the exponential function, basically if I have b to the power n, and I take the log base b of that value, I just get n. That's basically my log base b and my b undo each other, and I'm just left with the original value n, right? And so if I'm ever in a situation in algebra, right, where I have, let's say, let's say I have x is equal to 10 to the power 5, and I want to get this out of exponential terms and into logarithmic terms, I guess you could say I could take the log of both sides, the log base 10 of both sides. So in this case, it would be log base 10 of x is equal to the log base 10 of 10 to the 5, and the log base 10 and the 10 are inverses of each other and they go away, and I just get that the log base 10 of x is equal to 5. Okay, so that's just an example of the log and the exponential being inverses of one another. The logarithm function cancels the exponential function, and I just get the 5 to pop out. Okay, so that's just a brief review of logarithms. Logarithms have these important rules that make them very useful for Bode plots in particular. These 4 rules here. The first one here is that, they have it written in terms of p for power, because this is coming from the EE textbook. But basically, I could rewrite this one as the log of a times b. Basically, the log of two things multiplied together is equal to the sum of the logs. Okay. Let me get rid of my arrow here so I have more room. Okay. So that's just basically saying I can separate two things that are multiplied by each other into a sum of the individual logarithms of those things. And the same goes for a quotient. So if I have the log of a over b, I can take that to log of a minus log of b. Okay. For a log of something to a power, so if it's like a to the x, or let's just say log of x to the a, right? I can pull the exponent out, and I can say that it's just a times the log of x. And then the last one is that the log base anything of 1 is equal to 0. And we already discussed why that's the case, right? If I have any value x to the I don't know what, right? We don't know what this is, but we know that the answer is 1. This can only be 0, right? Doesn't matter what x is. If we need to get 1 here, that's just a power rule that we need to keep in mind when we do math, is that something to the 0 power is always equal to 1, okay? And so the inverse of that is that the log of any base of the value 1 is equal to 0. Okay, so those are the important rules of logarithms. We did a quick review of what logarithms are. In the next video, I'm going to look at some plots and talk about logarithmic functions that are going to be plotted on linear axes, and we're going to see what those look like. And then logarithmic functions that are plotted on logarithmic axes, so we can see what those look like as well. And we're going to discuss, again, why these are important for Bode plots. Okay, so I'm going to go ahead and end this video right here.